So we're going to be dividing polynomials by monomials, and it is based on the same kind of distributive property that we did for multiplication, we can do for division as well. It's going to mean that when we divide by 2 here, that the 4x squared is going to get divided by 2, and the 6x is going to get divided by 2. So just like we had arrows, that this 2 gets distributed to both of those. And then we have to simplify. Can you simplify 4x squared over 2? Can we simplify the fraction out front? Yes. 4 over 2, that simplifies to just be 2x squared. And 6x over 2 simplifies to be
3x.
Just 3x.
Yeah.
Okay? Now, you could have done this with regular numbers. Okay, but with regular numbers, you get used to doing other things. Like if I had 6 plus 10 all divided by 2, what's the answer? No, you don't have to write this down. Okay? Normally, what would you do in this question before this class? You'd do 6 plus 10 and get 16, right? And 16 divided by 2 is 8. That's normally what you would do in that situation. But it's neat to see that it works, that if you did 6 divided by 2 and got 3, and 10 divided by 2 and got 5, that 3 plus 5 also gives you the same answer. And the idea of this is based on adding and subtracting fractions. How do you add fractions? Find a common denominator. So if I had a common denominator of 2, then what could I do? If you find a common denominator, then you do what? You just add them, like add the tops and the bottoms, or just the numerator. So if I had this, then you would do 16 over 2, which is 8, which is the same thing we've been doing all along.
Whoa, look
Okay?
how that works.
So that's how you add fractions, but before you added these fractions, and this looks like a Z, not a 2, so I'm going to switch that up. That looks better. Before you added these fractions, what is 6 divided by 2? 3. And 10 divided by 2? 5. That would also give us 8. So it's that kind of idea. So when we get to our question like we had before, what we're kind of doing is we're kind of taking a step backwards from adding fractions. Because adding fractions says if you have a common denominator, you add the tops. So adding fractions would actually be going from here to here, right? I have a common denominator, I add the tops, I add my numerators together. But sometimes when we're dividing a polynomial by a monomial, we kind of go backwards. We say, if I'm dividing by 2, it means each of these terms is dividing by 2, and maybe I can simplify each one separately. So all we're doing is dividing each term in that numerator by what we have in the denominator. So as far as showing our work, what we do is our first step is we say, okay, here I have a binomial divided by a monomial. I'm going to take each term.
Do you have to write that down?
Yeah.
I wasn't asking you, so don't answer my question. Then don't look at her.
So we take each term in the numerator and divide it by 5ab. Then we can simplify. What can you do with the numbers? 5 divided by 5 is 1. So we don't have to write a 1, but we could if we wanted to. Can you see that the a's will cancel out? A divided by a, those ones will cancel out because it'll just be 1. And b divided by b will be 1 again. So what are we going to be left with in this first term? just c. While the 5 divided by 5 would also cancel out and just be 1. So we're left with 1c. We don't have to write the 1 in front. We can, we can write a 1 out there if we'd like to, but it's not necessary, so it can just go away if we want to. Okay? Now over here, what's 15 divided by 5? Can you see that the a's would cancel and simplify, and the b's would simplify, and we're just left with c plus 3, and now we've simplified our expression. Yes?
If it had equations.
An equal sign?
No,
An exponent?
exponent, yes.
Yes.
Would the exponents cancel out too?
Somewhat, and we'll see that in the next one. So the next one has exponents.
Even though like different numbers, or does it have to be the same number to cancel out?
Well, we'll look at this one, because this one has some different numbers here, right? So if we do each term divided by the negative 3x squared. Now here with the minus sign, we can just make that a subtract. And this is how we'll start. What is 9 divided by a negative 3? Positive or negative? What happens if you have x to the 6, which means repeated multiplication x times x times x times x times x times x, divided by x squared? You're going to be left with x to the 4. Does that answer your question from before? Abe? Now, here, what's 3 divided by negative 3? Negative 1. And a negative out front will be a negative 1. Will be a positive 1 in the end. Sometimes what I do is I just look at the numbers. 3 divided by 3, without thinking about positive or negatives, is going to be 1. And then I look, I have a negative out front and 1 negative in my fraction, and a negative times a negative is going to be positive. How many x's are we going to be left with? X times x, so we can write it as x squared. The next one, is it going to be positive or negative? It's going to be negative. Yeah.
Would it be negative x?
For this one here?
Yeah.
Well, we've got a negative and another negative.
Oh, okay.
So negative times a negative will make it positive. And 6 divided by 3 is? And an x cubed divided by x squared, you're going to be left with? Just an x.
What day is it today? March 3rd?
March 3rd. For the first one, 16 divided by 4 is 4. Your x's will cancel out, the z's will simplify away. And you'll be left with just 4y. The second one, we have to take a first step and rewrite them so it takes a little while just to rewrite this as our first step. And again, whenever you're doing your homework, I want you to be showing your work, because I know when you do your homework out of the textbook that you can check your answers, but just putting your answer in the back doesn't mean that I know that you know how to do it. So I want you to be showing your work as you're going. Make it nice and neat. Keep it organized. Now, 16 divided by negative 4. Negative 4. How many a's are we going to be left with? We have a to the 4 on the top, a squared on the bottom. A squared left on top. This is a 2. How many b's are we going to be left with? 1 b. And we still have a c squared and a d. The next one, is it going to be positive or negative? It's going to be positive. 4 divided by 4 is going to be 1. Because negative, subtracting a negative is going to be positive. A squared divided by a squared, those ones are going to go away. B squared divided by b squared is going to simplify, and you're just left with plus c. The third one, is it going to be positive or negative? Positive. 28 divided by 4? 7. How many a's are going to be left with? 1a. How many b's? There's 7 on the top. Oh, there's 2 on the positive 5 left on top. And finally, there's a d.
I got it right, except I put it in I do too. Shut up. I got it right?
So here's a couple of things that we could do in this one. First of all, we could write in that we know the area is 30x squared minus 25x. We don't know what the length is, but we know the width is 5x. Okay? So if we used regular numbers, and I gave you something like 42 equals something times 7, how would you do that?
42 divided by 7.
Okay, so one way you could do this to figure out this question mark is you say, well, the opposite of multiplying by 7 is dividing by 7. So if I wanted to find out what this question mark is, I could just take 42 and divide by 7, and then you'd figure out it's equal to 7 times what is 42? 6. There we go. So we get 6. That's one way we could do this. Another way you could do this, 42 equals something times 7, maybe you just know. What times 7 is 42? 6. So you didn't have to do. You didn't have to divide because you just knew what it was. Okay? So those are two ways that we could do this. We could have also made an area of 42 and said one side is 7. What would the other side have to do to give us that area? It would have to be 6. Now, we're going to take those ideas, of either dividing or multiplying or drawing our area, like we did with regular numbers, to this algebra problem. So one technique that we talked about was dividing. Another technique that we talked about was you just knew how to multiply what multiplied 7 by 6 to get 42. And another way is thinking about area. So let's start with the dividing. If I want to find out what this is, and I'm multiplying by 5x, the opposite of multiplying by 5x would be to divide by 5x. So if I did that, I would say, I'm not sure, but it's equal to 30x squared minus 25x, all divided by 5x. And that's what we've been doing today, is dividing by a monomial. When you do that, to show your work, you would say, well, the 30x squared has to get divided by the 5x, and the 25x has to get divided by the 5x. So the question mark's going to equal, what happens in the first one? 30 divided by 5 is? 6. And x squared divided by x? Just be x. Here the x's will go away. 25 divided by 5 is 5. So we know that this side has to be 6x minus 5. So that's using method number 1. We divide both sides just like we divided both sides when we were trying to find out something times 6 is 42. Now method number 2 says start off the same way. 30x squared minus 25x equals, I'm gonna start this on a new page because I want some more space. $30x squared minus 25x equals something times 5x. And if you just think about multiplying, how do we multiply something outside of brackets? What's that called? What's that called when we did the arrow thing?
Foil. It starts with a D.
Foil, if we did a binomial times a binomial, it does start with a D.
It's like
Distribution. Now, if you were distributing, blah, blah, if you were distributing the 5x and your answer was going to be 30x squared minus 25x, first of all, can you see that since there are two terms here, we're going to need two sets of arrows? What sign is going to be in between those two sets of arrows? A positive sign or a negative sign? It's going to be negative. We know it's going to be negative because we have a negative sign here. And then 5x times something is going to equal 30x squared. It's got to be 6 and x. Good. And 5x times something has to be negative 25. And so we get the same answer than we got when we divided. You like that way? Okay. And method number 3 is using the areas. Now, we know that our answer is 30x squared minus 25. And we know that, which side was it? We knew that this side was 5x. And we know that our area is 30x squared minus 25x. So instead of just writing 30x squared minus 25x in here, I'm going to split it up and say this part is the 30x squared, and this part is my minus 25x. Because that still shows me an area of 30x squared minus 25x. What has to be here to get the 30x squared? What has to be in this first part to get the 30x squared area?
6.
It's got to be 6 and an x. And what has to be here to get a minus 25x? Negative 5. So we get our answer is 6x minus 5 that way as well.
But if the answer is going to be positive 30,
Then it has to be positive 6x here to get the positive 30 here.
but the answer is negative 30. Is this supposed to
No, if we go back to the original question, it was a positive 30x squared minus 25x. Okay? So anytime you can either use your multiplication skills, your dividing skills, or just your skills with how area works to figure out these questions. They give you some different strategies to think about. So here's the homework you're going to work on for the last half an hour.